Hello, it's Dr. Mearson. Today we're going to be learning about normals. And when I say normal, I mean the normal line to the curve. Let's see what that looks like. We have a curve here, and in my last video we learned about the tangent. A tangent line comes and it touches that curve. Well, if we drew in a perpendicular line to that tangent line, that's called normal to the curve. We need to review some previous rules before we find the equation to this normal line. And the first one is perpendicular lines have slopes that are opposite reciprocals. So if a tangent line has a slope of m, then the perpendicular slope is going to be -1 divided by m. So if we have a slope of 4, then our tangent slope is going to be -1 over 4. Likewise, if we have, let's see, 1 over 2, then the tangent is going to be -2 over 1, and it just becomes -2. So that's what happens when we have perpendicular slopes. And the equation that we're going to use to help us make a line, to find a line, is going to be y minus y1 equals m, parentheses, x minus x1, where x1 and y1 are going to be points that we use, and m is going to be our gradient. I don't like how I wrote that. My apologies. Okay, my gradient, otherwise known as slope. Okay, let's start doing some examples. Number 1, the function f of x equals 3x squared minus 2 is given. We need to find, in part A, the derivative of the function at x equals 1. So first we have to take the derivative. So f prime of x equals 2 times 3 is 6, 2 minus 1 is x. This doesn't have an x, it's constant, so that just drops out. Now, after we take the derivative, we're going to have to input 1 into the function. So f prime of 1 equals 6 times 1, so f prime of 1 equals 6. So this is going to be our m, because remember, our m is our gradient, so our gradient is 6. Yay, okay. Now we have to find the equation of the tangent line to the curve. So we're going to have to find this equation first. This is part B. That's what we're going to be finding. So the equation of this tangent line. So we know that it has a slope of 6. Now we need an equation. So let's find that equation. We're going to be using, first, we need to find, we have this point, 1, we have x, but we don't have f of x. So we're going to need to find this point here. We have the 1, that comes from this. That's what this is, x is 1, but we don't have what f of x is. So what we're going to have to do is we're going to have to go back to our original equation. F of x equals 3x squared minus 2, and we're going to have to substitute this number in. F of 1 equals 3 times 1 squared minus 2. So f of 1 equals 1. 3 minus 2 is 1. So we went back to the original equation to substitute 1 for x. So that's what we did here. Okay, now that we have 1, we're going to put it here. So I have a point. So this now becomes my x1, y1. And I also have my m, which is 6. So now I'm able to actually find the equation. So what I'm going to do is just substitute it into my equation that we use. So y minus, here's y1, 1, equals, my m is 6, times x minus x1 is 1. So all I did was I substituted my numbers into this equation. Now, let's simplify it a little bit. I don't like these parentheses, so we're going to distribute. Y minus 1, 6 times x is 6x, 6 times -1 is -6. Now let's add 1 to both sides, because I'm going to put it in the form y equals mx plus c. So y equals 6x minus 5, and here we have our tangent line. And there we have it. Okay, so we have the equation of the tangent line. What do we have to do next? All right, next we have to find the equation of the normal to the curve at x equals 1. So now we have to go back, and we're now finding the dotted line equation. We found this one, y equals 6x minus 5. Now we have to do the dotted one. So that's part C. So you really have to look, when you're doing your problems, you have to look to see if it's asking you for the tangent one or the normal one and line it up to which work you need to do. So what do we have to do for the normal curve? Well, first we're going to have to get the perpendicular slope. So our original slope is 6. Now we have to transfer that to get the perpendicular slope, so that's negative 1 over 6. And that's the perpendicular slope. You don't have to write perpendicular out, but I just wanted to show you what it was. Okay, so now that we have a perpendicular slope, we're going to use that, and we're going to use our x1, y1. So all I did was I transferred this x1, y1, so we're going to use that again. So once we have that, we're going to use it, and we're going to use our equation. Y minus 1 equals my new slope, negative 1 over 6, x minus 1. Okay. Perfect, getting some points here. Now, let's just clean it up a little bit. Negative 1, 6x plus 1, 6 times 1 is positive. Negative times a negative is a positive 1, 6. Let's add 1 to both sides. Y equals negative 1, 6x plus 7 over 6. All I did was 1 over 6 plus 1 over 1. I found a common denominator of 6 here, 6, 6. So it's 1, 6 plus 6 over 6. That's how I got my 7 over 6. You could do it in a calculator as well. So what I did is added 1, and then I got y equals negative 1, 6x plus 7, 6, and here's my little show work. So very similar to what I did here, except I just had to take that opposite reciprocal slope. Now, if they ask you for parallel line, I just want to put a little side note. Parallel line or parallel lines have the same slope. So if you see that anywhere, find the equation that's going to be parallel, then you know to just use the same slope, which, we'll see. Okay, so just noticing that. All right, number 2. Find the equations of any horizontal tangents to the curve y equals 2x cubed plus 3x squared minus 12x plus 1. So we're going to need horizontal tangent lines. This is, yes, a multi-step problem, which is why you see that I have a blank space on my paper. So first, step 1, yelled at, take the derivative. Okay, so y prime equals 3 times 2, 6x, 3 minus 1 squared. Next, 2 times positive 3, positive 6, 2 minus 1, x. Then this is a 1, remember, 1 times negative 12, and then 1 minus 1, 1 minus 1 is 0, so that x drops out and that 1 drops out. The 12 does not drop out here, it just gets brought down. So my derivative, my y prime, is 6x squared plus 6x minus 12. Now what we have to do is, since we want to find horizontal tangents, we're going to have to solve, I'm going to do step 2. We're going to have to find our y prime. Remember, this is gradient. And the gradient of a horizontal line is 0. If we wanted to do vertical, slope of a vertical line is undefined. So it's going to have to be horizontal here. So our gradient of a horizontal line is 0. So our step 2 is going to be to substitute 0 in for our y prime. And our step 3, or actually part of this, is going to be solve for x. So we're going to put 0 in for y prime, and then we're going to solve for x. In order to do that, what I see here, I have 6, and I have negative 12. I can divide a 6 out. 6 divided by 6 leaves us with x squared. 6 divided by 6 leaves us with x. Negative 12 divided by 6 leaves us with a negative 2. All I did was I just divided 6 by everything, and I was able to rewrite it over. This makes it easier for us to factor. So 0 equals, I have to find two numbers that multiply to -2 and add to 1. And those two numbers are going to be +2 and -1. And I can even check over here. X times x is x squared. X times -1 is -1x. 2 times x is +2x. And 2 times -1 is -2. I combine the middle, I get x squared plus x minus 2, and that's what I wanted to get back to. So my check worked. Check, checked. Okay, so now, since I have my factors, I'm able to solve for x. So I don't need this 6, I can drop that out because all I need to do is take each parentheses, split it up, set it equal to 0, and now I can find what my x is. Subtracting 2 here gives me x equals -2. Adding 1 here gives me x equals 1. So I found what my x values are. Perfect. I don't want my x values, I want my horizontal tangents. Now, horizontal tangents are lines that go horizontally. So they go through the y-axis. So these are going to be y-equal equations because they're horizontal. This is a horizontal line, so it's going to be y equals. Here we have vertical lines. I don't want vertical lines, so we have to get the y equals. Well, how do we do that? We go on to step 3. We need the y values. So what we're going to do is substitute the x's into the original equation. And it's the original that you go back to because that's what we want the horizontal tangents. We want it to the original. So I'm going to write down the original. Y equals 2x cubed plus 3x squared minus 12x plus 1. And I'm going to take each one of these and I'm going to substitute it in. So the first one I'm going to do is x equals -2. So y equals 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 plus 1. And if you put this whole thing in the calculator, just like you see it with parentheses and everything, you're going to come out with 21. And that's our first horizontal tangent. And now we're going to have to do the same thing except for the other one, x equals 1. So y equals 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 plus 1. And again, if you put all of that into the calculator, you're going to come out with y equals -6. And that is my second horizontal tangent. And I have